Hello, this is video chapter 6.6, Rational Exponents. So in here, let's look at to see what our objectives are on our notes. So our objectives are we're going to write expressions with rational exponents. So first of all, let's go back. That sounds fancy. It sounds really complicated. What does rational mean? It means it's a ratio. What's a ratio? How can you write a ratio? There's three different ways. One of the ones that we use is fraction form. Okay, so that means an expression with fraction exponents, and we're going to change those to radical form and vice versa, and we're going to learn to simplify the exponential or radical form. All right, there's no vocabulary. So I put two of the key concepts boxes together because I think we can do them at the same time, and then we'll go through the examples together. So the first one says, when you have b raised to 1 over n, so you have a fraction, right, as an exponent. This whole thing is an exponent. We consider b our base. Okay, so, sorry, I'm not prepared here. So b is our base, and we have 1 to the n. So we've got a fraction as the power. This is our base. And even though we can call this also an exponent, when I'm teaching and I'm referring to properties, I'm referring to the entire 1b raised to the 1 over n. This whole thing, when I say exponent, I mean the base and the power together. Okay, so we can refer to the whole thing as exponent, or we can call the power an exponent. But when we're talking about teaching and power rules and properties, we're going to refer to exponent as the entire, the base, and the power together. So when you have 1 over n, okay, and b is not negative, and n is an even power, okay, the second key concept I will come back to and explain it. It's when b is raised to the x over y. Again, this whole thing, this is the power, and this is the base. So when your power is a fraction, I'm going to call it xy. Here it's just saying when it's 1. Here it's saying, well, the numerator could be anything. So we have the numerator. This is going to be the power of the base, and this is going to be an index. So whenever you have a fraction as a power, this means you're going to have a radical sign. Okay, you're going to have a radical where index n is y, and this is the power of the base. All right, so now this also means that b cannot be negative if you have n as an even power, because, and we'll look at it and see what it means. So basically they're saying you can rewrite this to say, because you have a fraction, I'm going to write it in green and move this down. I'm going to have a radical sign. My base is b. It's raised to the 1 or the x, if it's not 1, whatever x is, power. And this is going to be your index, y. Or in the case n, if it's 1 over n. All right? So the two concepts, the only difference is this is 1 as a numerator, and this means the numerator can be any real number, or any positive integer, excuse me. Okay, so let's do the example 1 and see what that means. So example 1 says write x to the 1/6 in radical form. Well, this is an exponent form, and I'm going to write it in radical form. So I know I'm going to have a radical. So this is my base. So it's going to go in here. My power of the base is 1. My index is 6. And there you go. And then we don't have to write and apply to the first power. We can just write x. Okay? Now b says write the 4th root of z into exponential form. So the first thing I need to identify is, what is my base? My base is z. My index, n, is 4. and my power of my base is an implied 1. So I'm going to have, so to write this, I'm going to have z is my base to the power of 1 over 4. So remember, x over y, power, index, which is n. Okay? So pause this, do the guided practice 1A through 1D, and then let's look at example 2. Okay, example 2 is just going on, continuing with this. Now we're going to have a numerator other than 1. So the rules for negative exponents also apply to negative rational exponents. So A says evaluate each expression, 81 to the negative 1/4. Okay? So let's first identify this. Our base is 81. The book doesn't teach this. Our index is 4, and our power is the negative 1. So this is our base, right? 81 over 1. To change the whole power to its opposite, I take the reciprocal of the base. So 1 over 81 to the positive 1/4. Okay, I can also write it like this, but we know 1 to any power is 1. Whether it's 0, negative, irrational, it's still going to be 1. So I don't need to write this. I can, or I don't have to. So basically what we've got going on here is we have the 4th root of 1 over the 4th root of 81. Now 81 you should know is 3 to the 4th power, and the 4th root of any root of 1 is just 1. So 3 to the 4th power raised to the 1/4. Oh, we can do it that way. And we've got the power, we can multiply it, and we get 1 over 3. Or a better way of looking at this for right now is the 4th root of 3 to the 4th. Okay, so 4 divided by 4 is 1, remainder 0. So I take out a 3 to the 1st, I leave nothing in, which I get 1/3 is my answer. Okay, so let's look at this next one, B. So we have 216 raised to the 2/3. Well, if I do the factor tree of 216, and I'm going to put this in parentheses, to the 2/3, because I can do that. 216, now this is, 216 is going to be what? 2, if you factor it out, you get 2 cubed times 3 cubed. Now, if you think about this, I've got one term, 2 factors, 2 different bases, 2 and 3. They happen to have coincidental, the same power. Now, don't I have a power rule of exponents that says if I have an exponent raised to a power, I multiply the powers? And that's what I've got going on here. As long as I have one term, I can distribute this to both of them. So I have 2 to the 3rd raised to the 2/3. And I've got 3 to the 3rds raised to the 2/3. Now, this is where you got to know your fraction rules really good. So 3 over 1 times 2/3 equals 2 over 1, or 2. So I'm left with 2 squared. This is the same exact thing, so I'm left with 3 squared. 2 squared is 4 times 9. So 16 to the 2/3 is 36. Okay. So that's one way of doing it. Another way of doing it is, so 216 to the 2/3, well, I'm going to have a radical. My index is 3. My base is 216 squared, which can be written as 216 times 216. And I already said this is 2 cubed times 3 cubed times 2 cubed times 3 cubed. I need 3 factors. Doesn't this 2 cubed by definition means 2 times 2 times 2? So I have 3 factors, so I can take 1, 2 out, 1, 3 out, I can take another 2 out. I'm doing 3 because my index is I have to have 3. And then I can take another 3, I have nothing left, and I'm left with 3. 6 times 6, which is, well, same thing we got. We just did it a different way. All right, pause this, do guided practice 2A and 2B. Now let's look at example 3. It's a real world problem. And this is just knowing how to simplify. So it says, refer to the beginning of the lesson. Suppose a video game system costs $390 now. How much would the price increase in 6 months with an annual inflation rate of 5.3? Well, at the beginning they give us the equation. This is little c, 1 plus r raised to the n. So n is the number of the terms in years. R is your rate. C is what the system costs now. Little c, and big C is what the system costs in whatever time period you have for n. So we have C equals, currently it's little c is 390. 1 plus our rate is 5.3%, which is 0.053. You gotta know how to convert. And it says in 6 months, which is 1/2, because that's a half of a year, because these are n is in years. Now we have to just put this in our calculator. So we do 390, 1.053 to the 1/2. So the first thing you're going to do, you can say 390 times 1.053 to the 1 raised to the 1/2, and then you should get approximately, if you put this in your calculator correctly, $400.20. But they want to know how much would the price increase. So this is the cost that's going to be in 6 months. So it's going to be this minus the original price, which is approximately $10.20 is what the increase is going to be in 6 months. Not what it's going to cost, but the increase. You have to read it carefully and see what the equation gives you. Pause it, do the guided practice. One last one, simplifying expressions. So you've got to know your radical rules, you've got to know your exponent rules, and you got to know what a rational exponent means. Numerator tells you the power of the base, the denominator tells you the index. Okay, so they want us to simplify a to the 2/7 times a to the 4/7. So what do I have here? Isn't this whole thing an exponent and this is an exponent? They both have the same base, which is a. So I'm going to use the product rule of exponents, which says you have x to the m times x to the n. You simply do m plus n. So I have the same bases and I have the product, so I'm going to do a to the 2/7 plus 4/7. So you're just adding the fractions. Instead of whole numbers, they're fractions. Or instead of integers, they're fractions. So how do you add fractions? Same denominator. So this equals a to the 6/7. And just like a fraction, you must reduce it, but this is a reduce. All right? And another way to write this answer is our index is 7 and a to the 6th power. So you got to know how to convert from one to the other. Let's look at B. B says, if you have b to the negative 5/6, all right? So what that means is 1 over. So you're going to change this first of all to positive. You always want your exponents, whether they're rational or integers, to be positive. So then it becomes 1 over b to the 5/6 power. Okay? So because it's a proper fraction or improper fraction, it doesn't matter. If it's not a whole number, then that means we have a radical. And we can't have a radical in the numerator. So I have to rationalize. So it's a fraction. So I have to multiply by some form of 1. And how do we do this? Well, we know that if we take the index, which is 6, minus the power, which is 5, right? Remember, it's index minus power, which equals 1. So I'm going to multiply this b to the first power. 1/6, sorry. 1/6. Because it's, yes, because I want this to equal 1 because we have fractions here. All right? So 6 minus 5 is 1. Okay, because if it's in radical form, it would just be b to the first. But because we have an exponential form, we have to put the index. Because normally this would say 1 over the 6th root of b to the 5th, and we would multiply by the 6th root of b to the 1st. Right? Index minus power. And how can you write this in exponential form? B to the 1/6. So when it's in exponential form, you have to put the denominator down here. Okay, so then we've got b to the 1/6 over, isn't this 5/6 plus 1/6? Fractions equals 6 over 6, which equals 1. So it's b to the 1 power. So this is how you would leave your answer. If you want it in radical form, it would be b over the 6th root of b over b. All right, pause this, do guided practice 4a and 4b. All right, now we're doing the last example, example 5, simplifying radical expressions. So the 4th root of 27 over the square root of 3. We said to divide fractions, we have radicals, we have to have the same index. We do not. So I can rewrite this to say 27 to the 1/4 divided by 3 to the 1/2, right? Because my index is 2, implied 2, and powers are 1. Now, I can't divide these. I have exponents, right? It's okay they're numbers and not letters, but my bases aren't the same. But I do know that 27 is 3 cubed, right? I can rewrite it to say this. Now, don't I have a power? This is the power raised to a power, x to the m. We already said that is equal to x to the m times n. So you have 3 over 1 times 1/4 equals 3/4. So this becomes 3 to the 3/4. You've got to know your power exponent rules. Over 3 to the 1/2. Now I have an exponent divided by an exponent with the same base. I'm going to use the quotient rule of exponents, which says x to the m minus n. So I'm going to have 3 to the 3/4 minus 1/2. You should know this one, but if you have to get a common denominator and then subtract them, know the rules for adding and subtracting fractions. This equals 3 to the 1/4. Or you can say the 4th root of 3. Both these answers are acceptable. Let's look at B. B says simplify the cube root of 64z to the 6th. Well, I can rewrite this. 64, isn't that 4 cubed? And so there's 2 ways of simplifying this. I can do 3 divided by 3 is 1, remainder 0, so I take out a 4 to the first power. 6 divided by 3 is 2, remainder 0, so I take out a z to the second power, and there's neither one of them have anything left, so this is 4z squared. The other way of doing it, the way the book shows you, is you can take 64z to the 6 and raise it to the 1/3 power. I know that this is 8 squared times z to the 6 raised to the 1/3. I can use the power rule of exponents because there's one factor, one term. So that's 8 to the 2/3 times z to the 6/3. Well, 6 divided by 3 is just simply z squared. Now this tells me I'm going to take the 3rd root of 8 squared, which is 8 times 8, and you should know that the 3rd root of 8 is 2, and you have another 2, nothing left. 2 times 2 is 4, so you get 4z squared, which is what we got earlier. All right. Let's look at C. C is a little bit more, it looks complicated, but it really isn't. You got to keep things straight. You got to know what takes on power. So you have x to the 1/2 minus 2 over 3x to the 1/2 plus 2. Now, because I have a rational, I know I have a radical. I can't have a radical in denominator, so I have to rationalize. Doesn't matter if it's an exponential form or radical form. You're going to multiply it by its conjugate since I have more than one term. So it's 3x to the 1/2 and, is that z? Oh, this is 2. I'll write my 2 correct. 2. And then you change the sign to its opposite. It's a fraction. You've got to do the same thing here. Now you have to realize that this 3 is not in the radical, because in order to be in the radical, it'd have to say 3x raised to the 1/2, just like when we have the negative. So that only the x is raised to the 1/2, not the 3. So we have two terms. So we know that these are conjugate. So the denominator, we're just going to do first times first. So 3 times 3 is 9. X to the 1/2 times x to the 1/2 equals x to the 1/2 plus 1/2, the product rule, which is x to the first. And then last times last, which is minus 4. They're not like terms, that's as far as you can go. Now in the numerator, we have to distribute x times to the 1/2 times 3x to the 1/2 is 3x, right? Because we already said x to the 1/2 times x to the 1/2 is equal to x to the 1, right? Because this was 2 over 2. 1/2 plus 1/2 is 2 over 2, which is 1. So first times first, outer times outer, minus 2x to the 1/2. Inner times inner, minus 6x to the 1/2. And then last times last, plus 4. So again, you're looking for like terms. These two are like terms. So you're going to simplify this to say 3x minus 8x to the 1/2 plus 4 over 9x minus 4. And please don't simplify. These 4's don't cancel out, nor do these 3's. That is simply your answer. Is leave it in that form. So pause this, do guided practice 5A, B, and C. We'll see you at the next lesson.